So in this video, we're gonna put all of our transformations together and practice doing them at the same time. So we had all of these types of transformations. We had multiplying by A on the outside, and A could be positive or negative. If it's negative, it's gonna reflect it vertically. Multiplying by B on the inside. And we always need, if there's a subtraction or addition of a number inside the function, we always need to have the B factored out, multiplied by parentheses. And then we have the H, which shifts it horizontally, and our K, which shifts it vertically up and down. So when we're graphing, the first thing is we factor the equation if X has a coefficient. So what that looks like is if this is my function, like that. This is not in the correct format because X has a number in front of it, which is that coefficient of 3. So what we're going to do is we're going to factor out the 3. And if we factor out the 3, we get X minus 3. And all of that's still in the squared. We have to do that first. And that's the only way to get both the compression or stretch correct, and then also the horizontal shift. You will have the horizontal shift wrong if you don't factor that out. Okay. So then we have that. And then what we do is we always first do reflections and stretch and compressions. You could do either one first, it doesn't matter, but we do that next. And we do shifts, adding and subtracting, the H and the K and this last. So we always do the A and the B first. It doesn't matter which one you do first. And then H and the K last. And again, it doesn't matter which one, H or K first. So for example, this one, we would first horizontally. Okay, so my B is 3. Okay, so I would horizontally compress by a factor. Remember, it's always 1 over B by 1/3. Okay, and what that means is we would multiply the X values by 1/3. And then second, and in this case last, we would shift, okay, by our H, which is 3, and since it's minus, it's right, shift 3 units right, horizontal shift 3 units right. Okay. So we would always, again, first compress, then shift right and left. If we had a negative, then we would reflect first, and then again, shift left or right. So let's practice with some of the stretches, compressions. So we have this function, which I'm going to call f of x, and we are going to graph both h of x and g of x. So this is f of x. And the first thing we're going to do is graph h of x, which f is 2x. So this 2 is inside. That's like my b is 2. And remember, it's always horizontally when it's inside, and it's a compression whenever b is greater than 1. So we're going to horizontally compress it. So compress f by, and then it's always 1 over b, so 1/2. Okay, so what does that mean? So what I'm going to do is I'm going to look at each of the x values, and I'm going to multiply them by that compression by 1/2, and then plot it with the same y value. So for example, I have -3, that's my x value. I would multiply it by 1/2, that's -1.5. And so instead of putting it at -3, I'm going to graph at -1.5, the same height, which is 0. And then I'm going to do that for each point. So at -2, I'm going to multiply that by 1/2, which is -1. And I'm going to I'm going to plot at -1, the same height. Okay, so I'm dividing each of these x values pretty much by 2, or multiplying by 1/2. Okay, so at -1, I'm going to multiply that by 1/2, and that gives me -0.5. And so I'm going to plot it here at 0.5. Okay, 0. Okay, now 0 times 1/2 is just 0. So if it's on, say, only the y-axis, or if x is 0, it's not going to change. Then I can do 2. So 2 times 1/2 is 1. So now I'm gonna, at the same height, I'm gonna plot it at 1. And then 3 times 1/2 is 1.5. So the height is 0. So I'm gonna now put 1.5. And so that is going to be my graph. So it's gonna go there, down here, up, and then down. So it's called horizontally compressed because it's not as wide left to right. It's like closer together left to right, which is why it's called a compression. So that's how we graph it from the compressions horizontally. Okay, so let's look at a vertical one. So now we have g of x equals 2 times f of x. Okay, this is a vertical, and now this is a stretch. Okay, and this is our a is 2. So it's a vertical stretch by 2, which means I'm going to multiply all the y values, because I'm stretching it by y, by 2. So this y value is 0, so it doesn't change. This y value is 6. I'm going to multiply it by 2, which is going to give me up to 12. So I'm going to have to extend my graph. So that goes all the way up to here. That's 12. And I'm doing my original. I'm ignoring my other one that I just drew. Sorry. Okay, here was 0. That y value doesn't change. This one was at -6. So then it's going to go there. Okay, but on this one, it's at 3, so 3 times 2 is 6, so I'm gonna plot, so I keep, in this case, the x value is the same, and I'm just doubling the y values, and then this y value again is 0, so that doesn't change. So then I'm gonna connect these. So I'm gonna go from here to here, down to there, up, and then down. Okay, and so that one is a vertical stretch. It's stretched vertically. All the y values are multiplied by 2, but it doesn't change horizontally at all. Okay, so that's how we do those two. Okay, so then just kind of a quick summary I have for all of them. I would really recommend like writing this down and studying this to know this. So vertical shifts are when the k is on the outside, f of x plus k or f of x minus k. If it's positive, it shifts it vertically up k units. So we move every y value up k units, or we add k to every y value. We don't change the x. If it's minus, we shift down and we move every y value down k units. Don't change x again. If it's inside, and we often call it h. If h is inside, it shifts it horizontally. If it's minus, it's right. If it's plus, it's left. So we're going to move every x value right if it's minus, and every x value left if it's plus. Reflection. Okay, so if you have a negative on the outside, it reflects it across the x-axis, which we say is vertical. We change the sign of every y coordinate, keep the x the same. If the negative's on the inside, we reflect it across the y-axis. We change the sign of every x coordinate, keep the y the same. Okay, and you might have to pause for all these to write this all down then. Okay, vertical stretches is when it's a times f of x on the outside. If a is greater than, sorry, this should be 1 again. If a is greater than 1, it stretches it vertically by a factor of a. We're going to multiply every y value by a. Keep the x values the same. It changes the output. The output is the y value. If it's between 0 and 1, then it compresses it vertically, and you do the same thing. You just multiply every y value by a, but now a is going to be less than 1, so it's going to be like 1/2 or 1/3. You can also divide each y value by 1/a. So example, like a is going to be like 1/2. So if you do 1/1/2, that's really just 2. So it might be easier to just think about like I'm dividing by 2 instead of multiplying by 1/2, especially if it's like a 3. I think multiplying by 1/2 might make sense, but it's often easier to divide by 3 than multiply by 1/3. And it changes again the output by a multiple of A. Okay, and then the last one is inside. So if B is greater than, again, it should be 1, then, and B is on the inside, it compresses the graph horizontally by a factor of 1/B. So we multiply all the X values by 1/B. Again, you can instead divide all the X values by B, we keep the Y values the same, so it changes the input by a multiple of 1/B. It does the same thing if B is between 0 and 1. So you're gonna change it by a factor of 1/B. You keep all the Y values by 1/B. Okay. And so again, we put them all together and it looks like that. So this is a summary of all of it. I'm gonna write all of that down. I also have this PowerPoint posted online that you could copy if you don't want to keep pausing the video. But this is really important to know.